Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. So this is about me. I am a computer science gate faculty having more than 5 plus of teaching experience, mentored more than 50,000 students, taught in different coaching institute all over India. Okay, it's like the Gate Academy, even qualified multiple times Gate, and even I have given the coaching in many government colleges as well as in many private colleges. Like in SRM Chennai, I have given coaching. CAT Bhubaneswar, I have given. BC Bhagalpur, Jorhat College of Engineering, Guwahati University, Dibrugarh University, Government College of Engineering and Technology, Jammu, Ramgarh Engineering College. Okay, these are the colleges where I have went and I have given the coaching. So we are now going to see a minimization of fine. Minimization of DFA. Now it's our next topic. So given a DFA in GATE exam, they will ask you to minimize that DFA, then how many states you are going to get. Okay, so that is minimization of DFA. So when you can say that, so आप कैसे बोल सकते हैं that you can merge these two states. So you have to see something. You write the state P and Q are said to be equivalent. They are said to be equivalent if okay, when P on seeing any string W, if it is going to one of the final state is going to one of the final state implies that Q should also go to one of the final state. It need not go to the same final state. On seeing any input string W, or if P does not go to final state, then Q should also go to non-final states on seeing W. So if any two states follow this property, then we can say that such two states are equivalent. Such two states are equivalent to each other. And we can say that such two states are equivalent to. Okay, देखिए क्या कर रहा है. The state P and Q are said to be equivalent. Okay, the state P and Q are said to be equivalent. When we can say that the two states P and Q are equivalent, when P owns in any string W, when P owns in any string W, if it is going to one of the final state, if it is going to one of the final state, implies that Q should also go to the one of the final state. It need not go to the same final state on seeing the any input string W. Means if P on getting W is going to final state, then Q on getting W, it should also go to the final state. It need not necessarily that it should go to the same final. It can go to any final. Or if P does not go to non-final state, or if P does not go to final state, then Q should also not go to final state. It should go to non-final state on seeing input string W. Then we can say that these two states are equivalent, and we can merge these two states, and we can reduce the number of states in minimal DFA. So if two states follow this property, then we can say that such two states are equivalent to each other. And okay, if length of W that is length W equal to 0, then both state P and Q are called zero equivalent. If length of W that is length W equal to 1, then both state P and Q are called one equivalent. Okay. So you can write, if length of W is equal to 2, then both state P and Q are called 2 equivalent. Okay. If it is equal to 2, then it is called as 2 equivalent. If length of W is equal to 2, then it is called, then both state P and Q are called 2 equivalent. Okay. So if length of W is equal to 3, then it is called as 3 equivalent, right? If length equal to 3, then it is called as 3 equivalent. When length equal to 4, then it is called as 4 equivalent. Similarly, when the length equal to n, then it is called as n equivalent. So please write it. If length of W is equivalent to 3, then it is called as 3 equivalent. You can write. So if P and Q are equivalent, so if P and Q are equivalent, then we can merge. P and Q are equivalent, then we can, so if P and Q are equivalent, then we can merge these two states and decrease the number of states in the DFA. Okay, we can only minimize minimize the can only minimize the DFA, not the NFA. So we can only minimize the DFA, not the we can only minimize the DFA, not the NFA. Okay, so we can do the minimization process on the DFA. We can't apply in the NFA. Understood? So as a summary, you can write what we have seen in minimization till now. It's saying that P and Q are equivalent. It is equivalent if extended transition function P by getting W if belongs to F, means P by getting some string if it's going to F, then it implies that Q should also go to final state, any of the final state. Then only we can say that PQ are equivalent, or if P by getting W not going to final state, then Q by getting W should also not go to the final state. Okay. And if length of the string is 0, then it is called 0 equivalent. If length of the string is 1, then it is called as 1 equivalent. Length is equal to 2, then it is called as 2 equivalent. Similarly, when length is equal to n, it is called as n equivalent. So you can write the procedure, how to do. These steps are very important, or you can say the procedure first use. Okay. So step 1 is saying identify the start state and final state. Identify the start state and the final state. Step 2 is saying if there is any state to which we can't reach from the initial state, then we have to delete. Then we have to delete such a state. So try to delete all the state to which we can't reach from the initial. So you can write here, step 1 is saying that identify the start state and final state. You have to identify the start state and final state. Step 2 is saying that if there is any state to which we can't reach from the initial state, then we have to delete such a state. Okay. So if you are not able to reach any state from the initial state, we have to delete that. So try to delete all the state through which we can't reach from the initial. This is very important. Then only we can apply the minimization procedure. Because if there is a state which we can't reach from the initial state, then why to include that state in the minimization? So we should delete that. Okay. If there is any state which we can't reach from the initial state, then we have to delete such a state. So try to delete all the states for which we can't reach from the initial state. Is it done? Then please let me know. Yeah. So minimization we have seen. So now after that we are going to continue. So you can write, we can merge non-final state. We can merge non-final state to non-final state only, but we can't merge with final state. So we can merge non-final state to non-final state, okay, but we can't merge non-final to final. Okay, so non-final will be merged with non-final, and final with final. Final will not merge with non-final. We can merge with final with final, non-final with final. This is very important, okay, because this, if you miss this point, you are going to miss some of the marks. Okay, is it done?